Welcome back, everybody. It's good to be back. It's been a busy year. We're happy that you're back with us and subscribing to our channel. In today's video, we're going to go over high humidity concerns involving package units on the roof, commercial application, whether it's single phase or three phase. We're going to go over common problems where water gets in to the building from the package unit, what you can do about that, what you need to kind of look for since this is a common occurrence. Additionally, when your ducts are sweating, um, we're talking about the outside of the ducts and that water is dripping down on ceiling tile or that water is dripping from the vents onto the floor. If it's a restaurant situation, anything that may invite humidity in that would collect on those surfaces and what you need to do about it and where to look. So stay tuned. Okay, getting right into it. I have a drawing of a rooftop package unit. We call them a RTU. Let's go ahead and go over the drawing. We have the unit itself. We got a condenser fan motor. We got a compressor, a condenser coil, a evaporator coil. It's obviously in cooling because the outdoor coil is in a high pressure. The indoor coil is in a low pressure, indicating cool gas, hot gas. Um, I put some heat strips there just to put them underneath the blower. Not that that's going to be relevant to today's lesson, but just to put that in there. Why not? And obviously, this would be my version of direct drive. There's no belts here. We have a return air plenum and a supply air plenum. Notice the arrows are coming up. As the hot air goes across a cold coil, heat is being transferred out of it, being rejected on this side, and leaving us with cooler air coming back into the conditioned space. We have this over here, which is our fresh air intake. So we're bringing in outside air with this. Anytime we have a commercial structure, we always want to bring in positive air. We're going to cover that. But let's go ahead and this is the curb here that the unit sits on, so that we can keep everything nice and dry so there is no water intrusion. All right. So what could cause high humidity? What could cause our ductwork to sweat? And I just put some key notes over here so we can stay on topic. Um, Oversized unit for the area. So let's just say that in commercial spaces, it's very common for one tenant to move out and then walls to be put up. And when those walls are put up, um, the space changes now. So now the demand of air now has to change, but typically it doesn't. We see this a lot to where maybe the tenant that was in there before, maybe it was a restaurant, it had a higher heat load, so maybe there were more air conditioners in place, or maybe they had just a high heat load in general. Maybe there was a large office requirement for people and equipment that was putting out a lot of heat, and they just upsized the RTU. That's very typical. We have to find a healthy balance so we don't go too crazy with these RTUs. Meaning, if we have a 5-ton and you require a 10-ton, sometimes it's better just to not put a 10-ton RTU on it. Maybe keep a 5-ton there, and then maybe add a 5-ton split system to the building. We've done that a lot of times just for this reason. This way, as the area is occupied and there's a different business in there, they may not need 10 tons. They may just need the 5-ton that was required for that volume of space. And then if they need some backup, they got another 5-ton split that they can turn on because it's still there. The landlords typically aren't going to get involved with equipment sizing because that's typically on the tenant's responsibility. In a lot of cases, everybody's lease structures are carved out differently. I don't want to get into that. But if you find that the unit is not running long enough, right, the thermostat's just satisfying, it's meeting its temperature demand, whatever the set point is, too quickly, then we're not going to remove enough humidity out of that space. We call that a short cycle. And so we see that a lot in commercial. So that is one thing that would cause high humidity. Now, that's not going to cause your ducts to sweat, right? That's just going to have a very high humidity. Typically, what we see in addition with that is if these fresh air dampers are not installed, right, then naturally there will be a negative pressure on the building, and there's nothing there to mitigate that negative pressure by adding additional outside air in. And then that high humidity that is left because of the result of a short cycle with no outside air adding to the structure to balloon it, then what will happen is you will reach a dew point. You'll drop the temperature so low that because the humidity is still at a higher level, that humidity is just going to start collecting on anything that's cold. So that's the beams that are in the um, above the ceiling grid, any steel beams, anything metal. If your ductwork is exposed, if you have something nice like some spiral ductwork or something of that nature, grills, anything like that, anything that has a metal surface, that metallic surface, is going to form condensation on it because the humidity is high and the temperature is low. And the moment we form condensation, eventually it's going to fall, just like when it rains, right? And so we start hitting those dew points, and a lot of the times, we've seen this many times in many structures where RTUs wind up getting replaced, and the outside fresh airs are not added back to it, or they're not ordered when the equipment's ordered and they're not put on. So that's actually a very big deal, and it's supposed to be caught on a building inspection when you pull your mechanical permit. The inspectors in that county that are there to sign off that things were done to the mechanical codes, that's one of the things. Just like you can't just sit these on the curbs, you have to anchor them down because there's wind and you want to mitigate against any strong gusts of winds. And so not enough run time or not adequate run time will shorten the cycle that it's running, and that's not going to allow enough humidity to leave the area. And that's kind of like step one of the problem. Step two of the problem would be if there is a negative pressure on the structure, then that humidity is only going to grow to a higher uh, uh, amount, and it's going to eventually reach dew point as the temperature starts to fall based on your cooling demand. Having too much fresh air is also not good. So if you have more outside air coming in than this coil can actually dehumidify, then you're going to raise the humidity in the building. So let's just say it's raining, and at the end of the day, it's not that much of a heat load, and the unit does not have to run that much, and more humidity is being added to the structure through the fresh air than is being removed from this cold coil. Then we may be coming in at, say, 55% relative humidity, but then maybe we're adding an additional 20% humidity, so 50 plus that's 70% relative humidity going across the coil that's not condensating at the same rate of the moisture that is taken in. So now you're going to be putting in a higher humidity back into it, so that humidity is really not going anywhere. So sometimes these fresh airs, they're open too much, and you need to close them off. Depending on what region you're in, if you're up north and humidity's low, you want to take advantage of some free AC. If it's not an economizer that can regulate and it's just a manual damper, you're going to have to understand your customer, understand the equipment, understand the lay of the land being the space that you're conditioning, and what their concerns are, so you can adjust the mechanical system to balance their requirements. If the fan is left in the on position, meaning the blower is left in the on position via the thermostat, you have auto on. If that is left in the on position, then what happens is, remember, we're pulling air from our fresh air into the package unit, and we're putting that back into the building through our supply. And if our compressor is not running, providing us a cold coil that we can condensate that humidity onto that cold coil, then what will happen is, if that coil is not cold, that humidity is just going to be added to the structure in between the cycles of the system coming on and running. So even if this mechanical damper is set to just barely be open, just enough to add enough fresh air to create a positive pressure, the humidity that's coming in by the fan being left in the on position is bad, because the thermostat should be in the auto mode, so the fan only comes on with a Y call. You don't want the fan to run unless it's calling for heat or it's calling for cool. You don't want the fan to run in the on position just to circulate air. Let's just say that you have negative pressure on the building and there is no positive fresh air damper to bring any air in to stop that negative pressure. Then the same thing with the fan in the on position, even without the needed fresh air, you're still bringing in negative pressure into the structure. So it's like a double-edged sword. It's like these fresh air dampers are there to stop intrusion of humidity coming in naturally and force any humidity being added through a cold coil. But the moment we leave these fans in the on position and we cycle that compressor off, we create a second problem that was induced by just operation error. The equipment also has many things that could relate to a high humidity. If we're having refrigeration issues, if the system is not charged properly, we can't get the temperature down on the evaporator coil enough to condensate that humidity coming into it via the return duct or the fresh air, in combination of both, then we're going to have humidity issues. So if the system's like undercharged, if the system's been worked on and it's no longer at its factory specs and somebody did not add enough refrigerant to it, maybe they charged it and it had dirty filters and they stopped ahead of time, but then the filters were changed out later on. We see that a lot, and it just needed a little bit more refrigerant, but nobody put it in there. We can have expansion valves that meter refrigerant to the evaporator coil, not regulating enough liquid refrigerant into the coil to get it down the temperature enough to where that moisture can be removed. Not getting enough liquid entering the evaporator coil, and just in general, if the specs are off. So say somebody swapped out the motor and they didn't go back with the same RPM, or they're running a too high of an RPM, for example. Say they pulled out a half horsepower and they put in a 1 horsepower. They put too much airflow there. Then the rate of air going across this evaporator coil is now going to allow the system to remove less moisture out of it. Condenser fan motors may not be turning at the proper RPMs because they were swapped out with something that's out of specs that now is not balancing the head pressure properly, and you can't get the right charge because of that. Anything that's going to relate to the refrigerant not being charged right because of either the demand of airflow on the condenser section or the demand of airflow here, anything like that is going to cause a higher humidity. Now, with regard to ductwork sweating, I'm going to go to another page to better explain that. That kind of talks about what happens below the roof deck. All right, so we got the RTU, we have the curb, we have the return, and we have the supplier plenum, and then this bottom line here, this would be the roof deck, right? And so we have conditioned space down here, we have the temperature above the grid and below the roof deck, and then we have the temperatures above the roof deck, which are both ambient and with the heat index, because that roof is just absorbing more heat than the surrounding air that's right in this area. So you got to think about it. You could have a lot of water standing here, a lot of sunlight adding more heat. There's more evaporation up here. Anything that can add more humidity back into the building is going to be a concern on some days versus others. But if we were to look at what I'm talking about below that ceiling grid in this diagram here, I just want to compare and educate you on negative pressure versus positive pressure. All right, so just to go over the illustration here, this top line is that roof deck again. And then again, here's our RTU. Now I drew some specs up here. We'll go over those. But we have our RTU, we have our return, and our supplier plenums here, right? Our curb. Now we have a kitchen hood here. And then we have the grease duct going up, and then we have the exhaust fan on top, which is exhausting the air that the hood is pulling up from the kitchen. We have the makeup air. That makeup air is, let me write that in there. Makeup air. Give me a second. We'll just write makeup there. All right. So the makeup air is pulling air in. The exhaust fan is taking air out. This area here between the two lines is above the ceiling grid, right? So we got the roof deck above the ceiling grid, and then we have what's below the ceiling grid. 3 different temperatures: a low temperature, a higher temperature, a very hot temperature, right? We're not really concerned with the temperature and the above the ceiling grid right now. But if you look at some of these temperatures that I wrote down, we have 100 degrees on the roof deck at a 70% relative humidity, right? And we're pulling that in. And that's not creating a problem because we're bringing in 3,000 CFMs of positive air into the kitchen, and then the exhaust fan, all right, that's a negative 3,000 CFMs out. So it's 3,000 CFMs in and 3,000 CFMs out. So it's unchanged and it's balanced. And then we have the RTU. My specs here, I put a 5-ton, which 400 CFM per ton nominal gives us 2,000 CFMs total volume that's going to move through that package unit. But if you look here, I have the supplier. There's that 2,000 CFMs going into the building. But if you look over here, I've got 1,800 CFMs coming out of the building, 2,000 CFMs coming in. And so because we have the fresh air opened up a little bit and we're adding about a half a ton of outside air in, that's 200 CFMs of positive air coming in. Yeah, it's hot, moist air coming in across that cold coil, right? But this is the 2,000. So we have 1,800 going in. We're adding 200 CFMs to it, and our total volume is still 2,000 CFMs. Now we're balanced here because we're 100% in, 100% out. But here we're pulling less air out of the structure, and we're adding 200 CFMs into the structure that was not there. All right. Now, if you look at what I have here for our conditioned space, I have 72 degrees at 47% relative humidity. That's below dew point, right? And so it's when this temperature either has to drop or that humidity, right, has to go up. And when they get really close, we're going to hit a dew point and things are going to start to sweat and water's going to start to fall. Here's the issue, okay? There's everything there. Rewind it 100 times, 1,000 times. Learn it. This is as simple as it gets. Don't take these numbers like you have to have 3,000 CFMs coming into a building and your kitchen hood taking 3,000 CFMs out. That's not the point, because maybe this is 750 in, 750 out. Maybe it's a small hood. Maybe it's 2,000 and 2,000. Maybe it's more than that. It doesn't matter. What matters and what you need to take away from this is these numbers are the same. Okay? What happens is these belts on these belt-driven motors, they slip, they crack, they break. Okay? When they flop off, when they're not running, when these motors aren't running, it could be a breaker, it could be anything. If one is running and not the other, they're going to have a problem. If the makeup air goes out, then you're pulling 3,000 CFMs out of your building. You just put the entire building in a negative pressure, right? How do you know that? Well, if you ever gone into a restaurant, right, and you open up the door to walk inside, and it feels like it's hard to pull that door open, it's because that negative pressure is trying to close it, right? And as soon as you pull it open, it feels like you're getting sucked into the building, right? And so that negative pressure, you're bringing in heat and humidity to a conditioned space, right? And so now that conditioned space, right, nothing can be going wrong over here, but now you're raising the humidity. And when that humidity spikes up and that temperature is still sitting over here, that humidity is going to collect on everything cold. So now vents are going to start to sweat. People are going to start putting trash cans out. Customers are going to get water dripping on their plate of food, their head, their clothing. They're going to be upset about that. Very common. And then technicians may not understand, why is there water on the vents? And very simple. It's the humidity that's in the air. It's reaching dew point, right? Because your humidity is high and your temperature and that humidity are very close, and you're just reaching a dew point, and water's going to fall. You need to understand that if you have a negative pressure, don't start looking at your RTUs. You need to come right back to that kitchen, and you need to make sure that this is turning at the proper RPMs. Make sure the belts are tight. Make sure the motors are spinning. Make sure the wheels are turning and you're pulling in air. Make sure that this exhaust fan is good to go. A lot of times what happens is people go to put in new exhaust fans because they fail and they don't match up the RPMs, the horsepower. And so now things that were originally designed to be, a combination to where they've been specced out to where these numbers are the same. One is now probably 3,000 or 4,000 RPMs or CFMs, excuse me, and the other one's 1,000 CFMs less. And so now you'll have an imbalance of airflow, creating that negative pressure. And the only way you can fix it is to go back to the source and make sure things are at specs. Common problem, very common problem. Another thing too to take into note is, if let's just say my positive air, say my positive air is working and my exhaust fan is down, and maybe the problem is the wiring that was done between these two, they don't both come on at the same time. I've seen that in older buildings where things really have just been kind of put together due to budgets and whatnot. So somebody comes over, they flip a toggle switch, the exhaust hood comes on, and your employee, they might forget to come over and turn on the makeup air. These things should be wired in unison, so when one comes on, they both come on. That's typically how it's supposed to work. And if yours doesn't work that way, it can be that way. You can just put a relay on it, and when this gets a call, that gets a call, and they come on. It's not hard. You don't have to change all this stuff out and give tens of thousands of dollars of business to the manufacturers. The RTU, just like we had on the previous screen, is going to typically have a fresh air on it. And if it does not have a fresh air on it because maybe the RTU was replaced and they forgot to put a fresh air on it, if you're in that situation, then your hoods can be off. You could be in a building where these aren't even on at the time, or maybe they're not even present, and your problem's just simply the RTU. So humidity is always going to be a concern in the event that the humidity and the temperatures are very close in range, where you are at that dew point to where things are going to sweat. I've been doing this for a long time, and I've seen a lot of wrong answers being relayed over to kitchen managers, and I've done a lot of second opinions, unfortunately, by a lot of local companies and whatnot. And it's all the same. I think everybody has the best intentions. I think everybody means well, but they're kind of passing on information that they were told and told wrong, and they're not really ascertaining what's going on here. And these videos are here to really help out the industry on some of these common problems, so we can just kind of better understand it. It's a lot of specifications that I put here, and I don't know how new you are to this, or if you've done this for so long and you just kind of tuned in and said, hey, let me see what this is about, and you're looking at it going, okay, yeah, that makes a little bit more sense now that it's drawn up. But it's hard to to explain this stuff without having all these specifications, because this is the whole picture. And if you had to sell this to a kitchen manager because something has to change here, and they don't know how to relay it, and it's confusing as it is because we're talking about negative pressure, show them this video. Just say, hey, look, here's an example of what we're talking about. Your kitchen hood is not in the same sink as your makeup, and you have a difference in CFM. So we are creating too much positive pressure or too much negative pressure. It has to be 100% balanced. And then over here, your RTUs, you have got to be bringing in more CFMs than you're taking out of the building. And the only way to do that, since the motor doesn't give you a difference, is to add some outside air to it. So 1800 plus 200 equals 2000 on a 2000 CFM RTU. 5 ton or whatever the tonnage is. If it's a 10 ton, it's 4,000 CFMs. If it's a 20 ton, it's 8,000 CFMs. If I'm doing that, yeah. So at the end of the day, it doesn't matter what it is. You don't want too much, and you don't want not enough. You have to have a good balance, and understanding that wherever you're at in the U.S., if you're in an area where there is already a high humidity, like we are here in Florida, then this is a big deal. This is a big concern, and we see this quite often. Maybe out west or up north, if the humidity is less, take advantage of some free air conditioning. It's not really going to hurt anything. If that was the case, if I was out west where it was drier and warmer, I would still want to have this balanced, because I don't want to invite heat inside, right? I may not have a sweating issue, but now I invited heat through negative pressure, and then I'm going to be having a hard time combating that heat because my RTUs aren't large enough to transfer that heat out of there. These RTUs are sized for the space and how many people are going to be there, and you don't really typically need more BTUs to transfer heat out of the place if you have proper makeup and exhaust, if it's a restaurant, because if this is off, then yeah, you're going to suck all your nice conditioned air right on out of here. These arrows might as well be blue at that point. But it's just air in, air out, right? So you're not really losing anything here. But if things are not balanced, then things are going to be out of whack, and you're going to notice it, and it's not going to be very comfortable, and you may even lose business, which is not good. All right, going back to ductwork sweating. I hope that explains it. One of the things that I see a lot of is people thinking that, oh, my ductwork sweating because maybe my drain line is backed up and water has leaked into my return or supply duct, and it's just a pool of water and it's just dripping. They wind up cutting a hole and they find out that the plenum's dry. They don't understand, why is there moisture on the outside of the duct board or the metal or whatever, anything metallic. Tape, for example, is got a metallic to it that will sweat. Maybe it just rained and the curb is wet, and they're thinking, oh, you got a roof leak. Or maybe there's things that have been done inside this package unit where people have drilled holes to bring in electrical whips, and those electrical whips aren't silicone very well, and you don't know where the water's coming in at. And maybe you're thinking, well, the pattern is every time it rains or it stops raining, they complain about there being sweating or water, right? We don't know if it's sweating or if it's just a leak. Is it the roof leaking? Is it the curb leaking? Is the unit causing a leak? Is there a backed up drain line? What's causing it? And it's very confusing, and a lot of people just missed a lot of things. The first thing you want to inspect, period, is, do you have a negative pressure? And if you have a negative pressure, then your negative pressure is going to be the culprit. And the easiest way to see if you have a negative pressure is you can crack the door open just a little bit. If all the doors are closed, front and back, open up the front door just a little bit, and you can just take a lighter and you can light it. And if that flame points inside the building, then you have a negative pressure. If the flame points outside the building, then you have a positive pressure. If the flame points straight up, then you're balanced. And that's not That's not a scientific thing where you can say, hey, you're balanced because the flame says so. You really want to take bolometers and whatnot, and you want to test things and make sure that a proper test and balance is done, and you're introducing more outside air than you are inside air, but through a mechanical system, not through the front door because one of these aren't working. All right, that's going to be it for this video. I hope that helps you out. Leave a comment. We'll read them. We lost our algorithm for a little bit and weren't putting out much content for a little while. We just got busy. My job is to do many things here, ideal conditions. One of them is to train technicians first thing in the morning. That's about an hour and a half to 3 hours sometimes before they get going. That's about a 6-month process. If you're looking to get in this industry and you are local, you can always see if we're hiring. We always start people off in the maintenance department, and we do not hire outside technicians. We want to do all of our training in-house. Make sure you come in with an empty cup so we can fill it up with knowledge. It's a big deal around here. Anybody that thinks they already know it all can't learn. Anyone who wants to learn more can learn more, right? So anybody can learn, but if you already think you know it, then there's no room upstairs for you to gather more information. If anybody's telling you something that does not make sense, ask them where they heard it and how, and ask them questions. Don't be afraid to ask questions. So if you're a junior technician and you're talking to someone who has more years of experience in the industry and they're telling you something that just doesn't really add up, or you can't understand what they're saying because you feel like it's just too complicated, start asking questions. And I'm not saying that what they're telling you is wrong, but maybe it's not explained right. And you want to be careful about what you're taking as true and passing on to customers and other coworkers too. So we want to make sure that we understand what we're doing so we can do it right. You want to make sure that you are practicing what you're doing safely. That's always a number one. And also make sure that you're doing everything by the book, right? There's only one way to do anything right in our industry, and that's by the book. There is no shortcuts. A shortcut is only a shortcut from doing something the right way. So you got to think about it. If there's a shortcut, you're doing something wrong. Just think about it. This is how long it takes to do something the right way. If you take a shortcut, you didn't go the full distance. It's like the starting line, the finish line. There's no shortcut to get to the finish line. It's the same way in anything else. So when we're practicing and we're doing things, you can't take a shortcut because you're not going to get the proper results. And those proper results would represent that finish line. So if you want to get to the finish line, you want to get there safely, and you want to win, you're going to have to put the work in. You're going to have to put the effort in. Please like this video, share this video with others. Very simple. There's a share button. Go and click it. Send it out to your buddies. Thank you for supporting us by watching this. We hope it helps you out. Normally we have longer videos. These next series of videos that I'm going to be releasing, they're going to be a little shorter, so a little bit easier to get through. And then we're going to just continue with it and try to put out more material as fast as we possibly can. Thank you for all your support. Thank you again. Stay safe and stay tuned.